Welcome back. So as we have started with electrochemistry, so that is part 2. In the last class we have discussed about the conductance of electrolytic solutions and electrolytic cells. We have discussed the theory, especially the theory we have discussed, and today we will solve some problems. So the theory was discussed in the last class, as well as 2 problems also we have solved. So we will try to solve today as many as problems as possible. So the first question that I am going to take it today. So this is the first question. The number of Faradays required to produce 20 grams of calcium from calcium chloride, molten calcium chloride. So atomic mass of calcium is given as 40 grams per mole. So what you need? How many Faradays are required? Faradays, how many Faradays is the question mark. And what is being formed to produce calcium from calcium chloride? From calcium chloride to get calcium. How calcium is present in calcium chloride? Calcium is present as Ca plus 2. Right? In calcium chloride, calcium is present as Ca plus 2 and Cl minus. We want only calcium, right? So this calcium plus 2 to convert into calcium, what we need? We need 2 electrons, right? So calcium plus 2 is converted to calcium by taking off 2 electrons. So as per our Faraday's first law of electrolysis, we said the number of electrons that are required to convert for the deposition of an element or for the liberation of element, that is nothing but that is the number of Faradays of electricity is required to form exactly the atomic mass of this element. What is the atomic mass of the element? Is 40 grams. That means 2 Faradays are required for 40 grams deposition or 40 gram formation of the calcium. 40 grams of calcium if it is to form, it requires 2 Faradays. This is how we have related in the last class, right? So the number of electrons that are required, so that is the number of Faradays which is required to form exactly atomic mass of that element which is going to deposit, or exactly the molecular mass of the molecule that is going to get deposited or maybe liberated. So our question, go for our question now. 20 grams of calcium to produce how many grams? Now we need 20 grams of calcium. What is the number of Faradays that is required? So just crisscrossing and getting the answer. So simple question it is. So 2 into 20 is equal to 40 into x. Let's consider it as x when it is x. Crisscross 40 into x, then 2 into 20. So here 40, here also 40 will get cancelled. That is equal to 1 Faraday. So what's your answer? The answer is 1 Faraday. Very easy question, right? Dead easy. So next question. During the electrolysis of molten sodium chloride, molten, he said clearly molten. Molten means without any water. Just it will contain molten sodium chloride, will contain only sodium ions as well as chlorine ions, no other ions, molten, right? So this should be kept in mind. The time required to produce 0.10 moles of chlorine gas using the current of 3 amperes. See, now the question is on chlorine gas. A gas always will get liberated. Last question was on deposition. This question was on deposition. Last question was on deposition. This calcium, this is on liberation now. So to calcium, to get produce the calcium, to get liberate calcium, so here the Cl minus should be converted to chlorine, right? So how Cl minus is converted to chlorine? So Cl minus is converted to chlorine by loss of 2 electrons, right? Because 2 Cl minus, by loss of 2 electrons, it will convert into chlorine. So clear? So 2 electrons are required. See, so let's go for the question now. 0.10 moles and 3 amperes. He has applied the current. The current is given as 3 amperes. Then the concentration is given. So the concentration is 0.10 moles, right? That is number of moles, which is the concentration. So now the question is, that means you have to relate by your first Faraday's laws of electrolysis, whichever we know already. So to form 1 mole of chlorine, it's very clear here, it is forming 1 mole, right? So when to form 1 mole of chlorine, we require 2 moles of electrons. 2 moles of electrons, right? 2 moles of electrons is nothing but 2 Faraday. 1 mole electron has 1 Faraday, 2 moles of electron means 2 Faraday. So we'll have 1 mole of chlorine to form, we need 2 Faradays of electricity. So here he has given 0. 0.10 mole. When it is 0.10 mole, how many Faradays? Let's calculate first. 0.10 mole of chlorine requires how many Faradays? Let's use X and just crisscross it. So this you will get 1 into X is X is equal to 2 into 1.20, you will get 2.20, 0.20 moles. That means how many moles? Sorry, 0.20 Faradays, right? What's happening? 0.20 Faradays. How many Faradays we require? 0.2 Faradays we are going to require. That means 0.2 Faradays are required. Faraday is nothing but charge, right? You got the charge, amount of charge that is required for the liberation. So of chlorine, you got charge, that is 0.2 Faraday. Each Faraday is how much? Each Faraday is 96,500 coulombs. Correct? These many coulombs are required for liberation of our chlorine. So we got I, we got Q, and we need T. So what is the relationship? The beautiful relationship between I and Q is Q is equal to I into T. Charge is equal to current into time. So that is, just substitute and get the answer. Q is, you got 0.2 Faraday, but whenever you are taking your current in terms of amperes, your charge should be taken in terms of, not in terms of Faraday, but in terms of coulombs. So that is the reason why I have multiplied by 96,500. Not to take in Faradays, you should take in coulombs. Whenever the it is taken in amperes, current is taken in amperes into T. So the answer you are going to get, the time you are going to get in seconds now. So that is 0.2 into 96,500 by 3 is equal to T. So when you solve this, you will get you can see from the answer, you need your answer in not in seconds but in minutes. So when you want in minutes, you can just do it here itself. T is equal to 0.2 into 96,500 by 3 into 60, because 60 seconds is equal to 1 minute. Just divide it by 60 so that you can get your answer in seconds. If you do it directly, you will get in seconds, but we want the answer in minutes, so that is the reason why we are going to divide it by 60, where you will get the answer as 107.2. This will be the answer. That means these many minutes are required, 107. So we'll look up the answer once. So there is no 107, so there is 1010, so which is near to 107. This will be your answer. So the answer should have to be given as 107, but he has given nearby answer, so that is 110 will be your answer. So hope you have understood. So the thing is very simple. First you need to write the cell reaction, then you should relate with the Faradays, then you should get the Q, so that once you get the Q and I, we can get the time. That's the reason why I have done all this process. So next, simple one. Next question. Here it says 250 ml of the waste solution obtained from the workshop contains 0.1 molar AgNO3 and 0.1 molar AuCl. Silver nitrate is there, gold chloride is there, both are same concentration. The solution was electrolyzed at 2 volts. The solution was electrolyzed by 2 volts by passing 1 ampere for 15 minutes. So the metal electrode potentials, the metal electrode deposited will be, so he has given the electrode potentials now. Silver electrode potential is given 0.80, and the gold electrode potential is given 7.69. So what he has asked you, the metal or metals electrode deposited will be either only silver will get deposited, or silver and gold will deposit, only gold will get deposited, or silver and gold are deposited in their atomic weights, proportion of their atomic weights. So now let's answer this. So in order to know this, we have to know that the deposition or liberation of an electrode, it depends upon what? Reduction potentials, right? Correct or not? So these reduction potential will decide you the amount of deposition or amount of liberation. So these reduction potentials, if you take silver, the silver reduction potential is 0.80 volt. That means from silver ion to form silver, we need only 0.80 volt is enough. And to deposit gold from gold ion, we need 1.69 volts are enough. And is passing the current, you can see 1 ampere of current is being passed. That to same amount of current is passed from the two solutions, right? The two elements are there, AgCl is there as well as, sorry, AgN is there as well as AuCl is there. He is passing same amount of current. Same amount of current when they pass, we can know that the Faraday's second law. The second law says when the same amount of current is passed, what he says that the metals will be deposited according to their atomic weights in the proportion of their equivalent weights. That is what second law says. So here he has applied 2 volts, again he has given, that means 1.69, 1.69 is less than 2 volts, so 2 volts is enough to deposit our silver. And here it is only 0.80, again 2 volts he has applied, so silver can also deposit. That means our silver can deposit as well as our gold also can deposit. Both can deposit. How? Both can deposit. That too not equal mass proportion, because whenever the same amount of current is passed through two different electrolytic solutions, we say that the amount of deposition is depends upon their atomic weights or equivalent weights, whatever we call. So the answer will be D. The silver and gold will be deposited, that too in their atomic weights, proportion of their atomic weights. So the question is so simple. So remaining whatever he has given, no, it might confuse you. So let's take out the next question. 4.5 grams of aluminium is deposited at cathode from Al plus 3 solution by certain quantity of electrical charge. Some quantity of electrical charge, certain means. So the volume of hydrogen that is produced from H plus ion solution by the same quantity of electrical charge will be. That means whatever the electrical charge that is used from Al plus 3 to convert into aluminium, the same charge is passed through this H plus ion solution. So how much amount of hydrogen is going to get liberated? That is our question. So that too you should calculate in volume. First we need to calculate two parts in this question. Now you need to calculate how much amount of charge that is required for aluminium to convert into aluminium, that to 4.5 grams of aluminium. So next, that amount of charge you need to take and you need to apply how much amount of volume of hydrogen that is being formed from H plus ions. So two parts in this equation. So let's take for the first part now, where 4.5 grams of aluminium is there. To form these 4.5 grams of aluminium from Al plus 3. So how Al plus 3 to form Al, what is required? We require 3 electrons, right? So you need to see how much amount of electrical charge. So you can see the amount of electrical charge here. Electrical charge you can get it from the number of electrons. Here the number of electrons are 3. So how much Faradays are required? 3 Faradays are required to form exactly atomic mass of this element. What is atomic mass of this element? Is given as 27 grams. To form 27 grams of aluminium, so we need 3 Faradays. So he has given only 4.5 grams. To form 4.5 grams of aluminium, you need how many Faraday? This is the amount of charge that you require. So this same amount of charge you have to you need to take and you need to use it so for the formation of hydrogen from H plus ion, and you need to calculate its value. So let's calculate this first. So that is cross multiply 3 into 4.5 is equal to x into 27. So you will get x as 3 into 4.5 by 27, where you will get answer as 0.5 Faradays. Right, we are calculating Faradays, right? So we got 0.5 Faradays. So this charge we will take up as case number 2. That is, this amount of charge is used to convert our H plus ion to H2. So when you are converting H plus ions into hydrogen gas, how many electrons are required? You need 2 electrons. 2H plus 2 electrons gives us H2. So you need 2 electrons. That means how many Faradays are required generally? You require generally 2 Faradays to form exactly molecular mass of this hydrogen. What is the molecular mass of this hydrogen? To form 2 grams of hydrogen, that means you require exactly molecular mass. Or you can consider, because your answer is being asked in volume, in terms of volume you can see, so you can say that whenever it is asked in terms of volume, you should not take in gram. This is not required for us. You should take in grams. So how many grams, how many volumes? Volume is nothing but in liters. Let us consider, because he has given the answer in liters, so we'll consider in liters only. Here it is 1 mole. 1 mole means 22.4 liters of hydrogen is formed for 2 Faradays. So but how many Faradays you have? You have only 0.5 Faradays. So 0.5 Faradays will form how much volume of hydrogen that is given. So let's take it as x and just crisscross, and you will get the answer here itself. So your answer will be, that is 22.4 into 0.5 is equal to x into 2 cross multiply 2 into x, 2x, 22.4 into 0.5, that is x is equal to 22.4 into 0.25 by 2. So by doing all this calculation, you will get answer as 5.6 liters. So what's the answer? 5.6 liters. So this is a way to perform. Or there is one more simple version for this to get this answer, because this is the traditional way of doing it. So there is one more simple version is there. What is that simple version is? He has given that same quantity of charge is being passed. He is passing the same quantity of our charge. Same quantity means same amount of current. When same amount of current is being passed through the two different electrolytic solutions, we can use our Faraday's second law. So what is Faraday's second law says? Our Faraday's second law says that the mass of the element deposited is directly proportional to its atomic equivalent weights. So that is, mass of aluminum by mass of hydrogen is equal to equivalent weight of aluminum by equivalent weight of hydrogen. This is what it is said by Faraday's second law, right? So when you apply all this, you will get the answer, because you are given with mass of aluminum is given as, mass of aluminum will be given as 4.5 grams. Then again he has asked you for mass of hydrogen, then equivalent weight of aluminum we have to calculate, again equivalent weight of hydrogen also we need to calculate. So let's solve this. So by using this trick also, so we will see how many possibilities are there to solve this question. So mass of aluminum is 4.5 gram, that is given in the question. By mass of hydrogen we need to calculate, then that mass we need to going to convert into its value. So equivalent weight of aluminum, equivalent weight is nothing but its atomic weight by its number of electrons that are required. So atomic weight is 27. So how many electrons required for its reduction is 3, by equivalent of hydrogen only H I am taking, so equivalent weight will be 1. So by its valence you can consider, so that you will get from this calculation. So this class, that is 4.5 is equal to 2.7 into 2.7 by 3, sorry, it's 27 by 3, right? This is So 27 by 3. 4.5 is equal to 27 by 3 into mass of hydrogen. So if you calculate this mass of hydrogen, you will get it as 0.5 grams. How many grams? 0.5 grams. So from this we need to calculate this into our volume, 0.5 grams into volume. So we know that 2H plus electron gives 2 electron gives rise to 2H2. This is our equation which we have got to get hydrogen from H plus ion. Same concept we need to use it here. So 2 electrons are required, that is 2 Faradays are required. So no need of taking all that again. So because to form 0.5 grams of hydrogen, you got mass of hydrogen 0.5 grams. If you see it here, 2 grams of hydrogen is used to form 22.4 liters of volume of hydrogen, right? Only one hydrogen is formed. That means 1 mole of hydrogen nothing but 22.4 liters. Then 0.5 grams of hydrogen requires how many liters? It will form how many liters? Just crisscross and get the answer. So you will get the answer again as 5.6 liters only. So this is another way of doing it. Either you can do by a traditional method, or you can do it by using the Faraday's second law of electrolysis. Any method is okay. Next question. So let's say this: the equivalent conductance of n by 32 solution of a weak monobasic acid is 8.0 mole centimeter square. Equivalent conductance is given, and at infinite dilution is 400 mole percent. Wherever it is given infinite dilution means that is molar conductance at infinite dilution is also given, limiting molar conductance which we call. So the dissociation constant of the acid is asking you dissociation constant. So what is dissociation constant formula? Dissociation constant K is equal to C alpha square by 1 minus alpha. So for that, C is already being given. C is nothing but concentration. The concentration is given. So we need alpha. Once you got the alpha, you will get the answer. So what is alpha? Alpha is nothing but dissociation constant. So how to get dissociation constant is, the formula is dissociation constant is equal to lambda m by lambda naught m. So these are the two formulas we need to use. First we need to get alpha, then substitute into this, you will get the answer. So what is being given? Equivalent conductance of monobasic acid is already given. So that is lambda m is given, equivalent monobasic, therefore it is taken as it is. So 8.0. So again at infinite dilution also given, that is lambda naught m is also given. Infinite dilution means lambda naught m is 400 mole centimeter square, right? So the dissociation constant here is asked. First you need to get alpha. Alpha is equal to lambda m by lambda, and lambda m is what? 8 by 400. So where you will get 0.02, right? 0.02. Next, this we need to use to calculate K. So that is dissociation constant. This is a formula. We need to just substitute that alpha there. So that is K is equal to C into C is how much? M by 32 means 1 by 32, right? Into C alpha square. C into alpha square. What is alpha you got? You got alpha as 0.02 square by 1 minus alpha. When you take 1 minus alpha, see, there will not be much change in the value of 1 minus alpha. 1 minus 0.02, where you will get nearly 9.98 like this, right? Which is nearly equal to 1 again. So there will not be any change in this value. So you can just neglect it because it's nearly equal to 1, right? Just neglect it, no problem. So you will get from this calculation where you will get K as, so you will get K as 1.25 into 10 to the power of minus 5. So the answer is 1.25 into 10 to the power of minus 5. Very simple. You are given lambda m, lambda naught m also given. Just calculate alpha. Just you need to calculate some constant. So just substitute here and getting the answer. So simple question again. Next one. So 0.1 mole of MnO4 minus 2 is oxidized. The quantity of electricity required to completely oxidize MnO4 minus 2 to MnO4 minus. So amount of quantity of electricity is asked. You can see the option. The electricity is given in the terms of coulombs. That means is given in the term answer in the terms of charge. So we need to calculate the charge here. So let's see what is being asked. MnO4 minus 2 is converted to MnO4 minus. How many electrons are that is being transferred? That is important for us. If you calculate in manganese, oxidation state of the manganese, so if you take it oxide minus 2 into 4 minus 8 minus 2, it will be 6. So oxidation state of manganese will be 6, whereas in MnO4 minus it will be 4 to the 8 minus 1 7, so it is 7, right? Manganese oxidation state became plus 6 to plus 7, that means there is loss of 1 electron, right? To convert that MnO4 minus to MnO4 minus 2 to minus, so you require 1 electron. 1 electron means how many Faradays beta? You require 1 Faraday to convert 1 mole of MnO4 minus, right? 1 mole of MnO4 minus 2 requires 1 Faraday. You may ask me, sir, why you have taken MnO4 minus 2 as 1 mole? Because from the question you see, your question is on 0.1 mole of MnO4 minus 2, right? So always the question should be kept in mind when you are solving it. So 1 mole of MnO4 minus requires 1 Faraday. 1 Faraday is nothing but 96,500 coulombs. Because your answer is in coulombs, you need to take it your calculation also in coulombs. So what's your question? 0.1 mole of MnO4 minus requires how many coulombs? X. Just crisscross and get the answer. 1 into x is equal to 1 into x is x. Crisscross 0.1 into, you should take only coulombs, 96,500. so where you will get 9650 coulombs as your answer. So answer is simple, 9650. Simple relation. Just you need to write the equation first. After writing the equation, get the number of electrons, that means how much charge is being displaced, change in the charge, depending upon that how many number of electrons are involved, thus many Faradays. If the answer is given in F Faradays, no, you should take only in Faradays and you should calculate, that is 1 Faraday and you should calculate. As your answer is given in coulombs, that's the reason why a Faraday is converted to 96,500, and that 96,500 we have used in the calculation of our problem. So next question. Now the number of electrons delivered at cathode during electrolysis by a current of 1 ampere in 60 seconds is. The question is how many electrons are that being delivered at cathode, how many electrons being delivered when your current is 1 ampere and 60 seconds. So number of electrons we require. So what is being given? So let's try that. That is current is given as 1 ampere. Then you are given the time is 60 seconds. Then once you are given I and T, you can have a guess that you can get Q here. That is Q is equal to I into T. Charge is equal to ampere, that is current into time, that is 60 seconds, right? So 1 into 60 is equal to 60. So this is the coulombs. You will get your answer in coulombs. How many coulombs is there? 60 coulombs of charge is being passed. So he has given you the charge on electron is 1.60 into 10 to the power of minus 19. That is a charge on 1 electron. That means 1 electron will have charge of 1.60 into 10 to the power of minus 19 coulombs. Then 60 coulombs will have how many electrons? Because you need number of electrons, right? This is a charge that is being transferred. So 60 coulombs we got, but we need number of electrons. So 1 electron has got these many number of coulombs. Then 60 coulombs will have how much amount of electrons? So just crisscross and getting the answer. That is only the simple thing. So that is x into 1.60 into 10 to the power of minus 19 is equal to 1 into 60 is 60, or x is equal to 60 by 1.60 into 10 to the power of minus 19. So if you calculate this, you will get the answer. And